Um, Today's 5.1 is stuff we've mostly done in the past. There's a few things that I want to point out for us to pay close attention to move forward with this chapter, but I like that it's a lot of review. Remember, we've learned about y equals mx plus b. This is our slope-intercept form, and we like this one because it's easy to graph. It's also easy to write the equation if you have the graph. What we have to remember is that m is the slope, or rise over run. Lots of other ways to express that. Delta y over delta x, triangle y, that's change in y over change in x. And we've looked at a number of different ways to get that in the past. And the other thing is the y-intercept, the b. Now, both of these are important. This is the guy you start with. When we're graphing. It's our starting point. So it's the number that's adding or subtracting in the end. We call that the constant. I didn't write this. I know what this teacher who wrote this was thinking, this label your slope with possible direction arrows. A while ago I had you take notes about slope. And if it's a positive slope, it's going up to the right. If it's a negative slope, it's going down to the right. So 2/3, there's no negative in this slope, so it's going up to the right. But another way that I want you to think about this is rise over run. It's a pretty bad I there. There we go. Rise over run. And so in the 2/3, it gives us directions. It's telling us, hey, we need to go up to, from some point, and over 3. To make this angle work, this tells us how much up and how much over to get to the next point. Now on the negative 2/3, this is a negative slope. It's going down to the right. Here's the thing about the negatives that students sometimes get mixed up is they maybe aren't real comfortable with fractions or whatever, but are both numbers negative? No. The whole number 2/3, or the whole idea of 2/3 is negative, but not both numbers, the 2 and the 3. So we get to pick where does the negative go if it's not attached to one or the other. And we could change it if we want anyway. So I could say this is negative 2 over 3, which would mean that I'm going down 2 and to the right 3. Or I could say 2 over negative 3. It's the same thing. It doesn't matter where you put the negative, it's the same thing. So this would be up 2 and back to the left 3. So we're going to get a lot of practice on slope. Let's have a look at some of these problems. These are sort of our warm-up problems today. So looking at number 1, I've got y equals mx plus b. Now, sometimes when I ask students what's the slope, they'll say mx. The x doesn't factor into the slope. The slope is what happens to the x. It's the what's going on. It's what's happening over and over again. So I've got the 3 and the 4, but I need to know where to start that with. And that's going to be this guy right here. This is the b. So this is the y-intercept. I go to 2 on my on my y-axis. Looks like it's about here. Zoom in a little bit on that. Put a point. So that's your starting point. Now, this gives us directions on how to get to the next one. It's a positive slope. The rise and the run are up and to the right. So I'm going to go up 3 and over 4. And I can take that backwards. Positive 3/4 is the same as negative 3 over negative 4. This is why we don't make fractions that are negative double negatives, because what's a negative divided by a negative? Positive, right? And it shows up here. If I go down 3 and back 4, I'm still in line, right? And if you really want to make some nice pretty lines, a good straight edge that you have on hand is your ID. Makes a great straight edge for this stuff. So, if you wish. Let's look at number 2. So now we have a negative slope and a negative y-intercept. So I'm going to start with the y-intercept of negative 5. So down here to negative 5. Now, you get to pick. Is the 5 going to be negative or is the 2 going to be negative? If the 5 is negative, I've got to go down 5. And that's kind of taking me off the graph. So maybe I make the 2 negative. Do something like this, perhaps. So this is going to be up 5 and back 2. That looks like that would fit better. Instead of going down 5 and over 2 and falling off the graph. And I could do that a couple times. It's like stairs. The pattern repeats. So far, so good? All right. Let's look at number 3. 3 throws us a little bit of a curve. I don't know if I talked about this last semester or not. What's the y-intercept here? How do you know it's 0? Because it's not written, right? You're absolutely right. The y-intercept is 0. We've got a slope but no y-intercept. Why wouldn't they print the y-intercept? Why wouldn't they just put +0 there? It's actually an economic reason. I remember learning about this sometime years ago. I think I might have been your age. When they're printing textbooks, the most expensive part of printing is the ink, by a long shot. Think about your copiers at home or your printers at home, right? If you have an inkjet printer, like you can go buy a new printer for less than you can buy just the ink for the printer half the time. So the expensive part is the ink. So by not printing stuff that wasn't absolutely necessary in the math books, they were able to save on the cost of ink. So they wouldn't write it this way because it would save them, you know, maybe a few cents per book. But if you start talking about making, say, 1 million copies of a book, a few cents starts talking about a lot of money, right? So 0 is the y-intercept. It's not written, so we'll go to 0. And then my slope is 5 over 4. They're both positive, up and over. So up 4 over 5. Up 4 over 5. I really only need 2 points. You can work it backwards if you want. Something like that works. Let's go down to 6. I'll go through the ones that I want you to go through since we're recording here, and then I'll let you come back and work on these others. This is the same thing, same kind of thing. We don't print what's not necessary. So I've got a y-intercept of -2, but what's the slope? 1, right? There's 1x, but we don't write 1 there. We can put it in, but they're not going to print it for us. And if I make that 1 over 1, because I need it to be a fraction, This is going to be a rise of 1 and a run of 1. So up 1 and over 1. It's a simple one. It's just a 45-degree angle there, if you know your degrees. How are we doing so far? So this should be stuff that you know. This should be stuff that's not that new. But if you'll open to the next page, they throw us a couple of curves. And we've talked about these too in the past, but it's been a while. Special cases, number 7 and number 8. Now, in these, they're very easy to graph. They're sometimes the easiest things to graph, but sometimes the easiest stuff tends to be most confusing too. So the question that usually happens is when I have a student ask me about something like this is I very rudely answer the question with another question. So how do you graph this? I say, well, show me where y equals 4. So where does y equal 4? And just about 99% of the time they tell me right there. And I go, yeah, great, put a dot there. And then I say, well, where else does y equal 4? And a lot of times I'll get, here? No, that's negative 4. Here? No, that's x equals 4. What am I missing, Allison?
Like all the x values?
Right. So where else does y equal 4? Everywhere along here and everywhere in between. So it's a horizontal line with no slope. So I shouldn't say, when I say no slope, it actually does have a slope. What's the slope of a horizontal line? 0, right. And we could write this as y equals 0x plus 4. There's nothing wrong with that. But again, we get to that thing of, hey, if we're printing and we're using ink, we want to save as much money as we can, so we only put the stuff that we absolutely need. And 0 times anything is 0, so we don't really need zeros. So I can write this one in slope-intercept form. I cannot do that to this one. And the reason for that is, well, sort of not there is no slope. It's the slope is a massive problem here. So where does x equal negative 2? Here. And right, everywhere above and below. So this has an undefined slope. You don't have to write that, but I do want you to know it. The problem with an undefined slope is this. On any other slope, if you were, say, on a mountain bike riding down the slope or up the slope, you could sort of imagine it happening. But what if this was an infinitely long line, and you tried to ride your mountain bike down this infinitely long line? What's going to happen to the mountain bike rider trying to drive or ride down this undefined slope? Are they going to be very successful? Not at riding. They'll be quite good at falling, right? But not a very good rider. Now, on bikes, you can go down vertical slopes for a very short distance, right? You can pull that off for a very short distance, and then it has to curve out. But otherwise, this is a problem. Okay, there's no way to control that. So that's why I think of it as how I think of it as undefined. If I was riding a bike down that, I couldn't control the bike. Pretty soon the bike and I would just be falling. Okay, so let's look at one of these guys here. What about number 9? Then we'll move on to the part that's sort of new that I definitely want you to be aware of. So we want to write the equation for this. And we're going to put it in y equals mx plus b form, slope-intercept. I'll put that up here just to kind of remind me. Now the only two things we can get off the graph are the m and the b. The y and the x, they're variables. They're all sorts of things. So what I like to start with is the thing that I would start with graphing is I find the y-intercept first, -4. And then I've got to find the slope. So to do that, I've got to find another point where it sort of crosses an intersection of the grid. So anywhere that I find one, it looks like there's a bunch of them here. So I can find the slope. Is this a negative or positive slope? It's negative. It's going down to the right, yeah? So m is negative. And my rise is 2 and my run is 1. I can write that just as -2 if I wish. Up 2, back 1. Right? So my equation then is y equals -2x minus 4. Once you know the m and the b, you just have to put them in their slots. Don't forget the x. I see a lot of students just, it's not like they don't know it belongs there, they just forget to write it. So careful about that. Alright, I'll leave you guys to the rest there on that page. Let's look at this one. So in this one, the instructions are to graph the equation on the grid, and then we want to see if 0.35 is a solution to the equation. Well, when we graph it, every point on the line is a solution to the equation. We just don't know if this is one of them. So I'm going to start by graphing this. So 6 is the y-intercept. Go up to 6 here. And now my slope is negative, -1/3. I'm going to graph that as -1/3. But I think it doesn't really matter on this one, because there's plenty of room to get some points in there where you put the negative. So I'm going to go down 1 and over 3. I'll do that a few times, get a few points in there. And I could do that backwards. I can go up 1 and back 3. Now the question is, to finish this up, is this a point on the graph? If I go to 3, 5, okay, we do a lot with slope, rise over run, rise over run, rise over run, but then when we go back to a point, we have to remember that that's the opposite. It's x and then y. So if I go over 3 and up 5, do I land on the line? And yeah, I sure do. 3, 5 is a solution. Oh wait, I circled the wrong one. Not that one. This one. I know it's a solution because it's on the line. Alright, the new stuff. Sort of new. Alright, I'm going to let you guys go here in just a minute. Let's look at 17. They're giving us 3 ordered pairs, or at least part of ordered pairs. And they want us to find out what makes that true. So the thing that we have to notice is this isn't a different form. This isn't slope-intercept anymore. This is standard form. And standard form is just another way of writing an equation of a line. I know it's linear. Does anybody know why I know it's linear? Yeah.
There's no exponents.
Exactly. There's no exponents. So it's linear. It's going to make a straight line. So what they're telling me here is when x is 2, what's y? So I'm going to have to take the 2 and I'm going to plug it in for x. So this is going to be 3 times 2 minus 2y equals 12. So the x is replaced by the 2. This is going to become 6 minus 2y equals 12. And if I subtract 6, careful you don't drop the negative there, negative 2y equals 6. And if I divide by negative 2, keep working this down, I get y equals negative 3. So when x is 2, y has to equal negative 3 for this to be true. Now, the next one I like a lot better than this one. You know why? Yeah, why do I like zeros? That's right, because they're easy and I'm lazy, okay? And you should be a lazy but good math student. So there's nothing wrong with being lazy as long as you're still doing the work. It's just if you get to pick stuff, zeros make a lot of sense. So this is going to be 3 times 0. I'm replacing the x with 0 minus 2y equals 12. What makes this easy is the 0 cancels that out. And I just have negative 2y equals 12. Divide by negative 2 to get y equals negative 6. And then the last thing, instead of plugging in the 0 for x, now they're going to ask us to plug the 0 in for y. No problem. So this is going to be 3x minus 2 times 0 equals 12. The 0 and the negative 2, that's multiplying, so that goes away. It cancels and becomes 0. I don't need to write it anymore. And so x equals, divide them by 3 there to get that. Now, aside from these being easier, there's another reason for plugging in zeros. Anybody know why? I think the next page is blank. Let's turn to the back page real quick. We're going to put just a quick sketch on here and some ideas. If I have a grid, an x and a y, and I graph a line that looks like this, let's say. So here's my equation. It comes through there. I don't have any numbers on the grid. I didn't give you the equation of the line, but we can still say some things about some points here. This point right here, what do we call this? That's the y-intercept, right? So this is the y-intercept, and I know something about this for sure. I absolutely know x, but I'm not sure about y. I could say that y is positive, but I know what the value of x is. What's the value of x? 0, right. Yeah, it's above the 0. X is always 0 for the y-intercept. This one is the x-intercept. It's important, but we haven't done a lot with the x-intercepts yet. That comes into play, I think, a little bit more next year, but we certainly want to know about it. Now, I don't know what x is. I could say that it's negative, but I don't know anything else about it. But I absolutely positively know what y is. What's y? 0, right? And it doesn't matter what the lines do. It doesn't matter how the line comes across. Here, this is always going to be 0y And this is always going to be x0. X's and O's. Doesn't matter where on the x-axis we cross, y will always be 0. Doesn't matter where on the y-axis we cross, x will always be 0. So when you plug in zeros, you get some really important parts on the graph. Okay, so I'm going to give you guys about 10 minutes or so to work through the problems that we didn't work through. I'll come around and answer questions. Feel free to ask. Then we'll go over some answers and get you going on the assignment. Yes?